you reproduce it. And then, I was supposed to give a diagram electrolytic scenario, which my equation too. But then, don't deduce from this. Then I would combine them into an overall equation. But then, as deduce, that's not just pure. Do it as recall. So the question is misleading by able to deduce. Otherwise, you're going to reproduce the same equation in the book. That's the equation is now into Sangana. But you should also check is it possible to combine, can you comfortably combine those two equations into the overall equation? So make a sense. Do you know how to cancel spectator ions? Huh? You should balance your electrons and cancel out spectator ions and my electrons. Cancel my electrons. It's not good. Anything else, guys? Sapatika gumira isusu takazogumira pekuti taitaura nezve, so we did KC, KP and all those things, pH, POH, what is that? Calculating the pH of, for example, calculating the pH of water given its ionic product, calculating the pH of a base. If I dissolve sodium hydroxide into water, can you calculate the pH of a strong base using KW? KC, acid dissociation constant. What are the strong acids? What do? They have a high value of Kc, So, from the look of things, you understood that section, So let me just maybe add one more thing and then we are done. Can I ask some questions? Can I ask some questions? I think we have met our objective. Solubility, Panama graphs say solubility, Mangamona. Sorry, put a solubility. My graphs say order, Nafuga order. My graphs say order, Mangamona. But you can plot, instead of just using the equation, or using experimental data, you can use graphs to determine the rate here, rate, and this is concentration. Rate concentration, sorry. I can have A plus B to give C plus D. If this one is the simplest because no which are exactly what I would run about to change the concentration and see what happens to it. I'm increasing my concentration. What's happening to it? So what is this? Order. Is zero order. But not going to put a gorga. Okay, fine. I don't know what so could a curve. What do you think this is? Second order. Correct? So these shapes should tell you the order. So the question I'm going to plot, you need to plot here. Maybe you can determine order from this rate concentration graph. And then position of that specific reagent that you're interested in. It could be B or A. Right, because later you can plot concentration versus time. Concentration versus time. This one is another graph that you can come across. If I put my concentration here, and I say time, that is very general about concentration time graph. A plus B to give C plus D. What should happen to these concentrations? Arrow, solid arrow. Let's start with solid arrow. So I'm changing A and B to C and D. In general, I should expect my concentration of A to decrease over time, and my concentration of B to also decrease over time. Whilst my concentration of C increases over time, and my concentration of D increases over time. Yes, those are some of the things that you need to know in general. So, but ukazoplota concentration versus time, ukaona ichidai. Concentration versus time. Concentration yako iri kudecrease. Ndozo zorewa. It's decreasing with time, isn't it? But at a constant what? Rate, isn't it? What is it? Gradient is constant, isn't it? Gradient is farana. So this is zero odd. Regarding or it's zero odd. Choose one. Then zvinoitika manje first order inoita gentle slope yobva yazodai. This would be first order. Then second order inoita a similar, this is unfortunate, inoita a similar shape but zvinozoti siyane. It will tail off earlier. So there's first order. Did I say second? This one? Yes, second order. Here better first. So that was what I imagine. This graph becomes unreliable because of that. But obviously for zero order it's obvious. But when I know much, you wouldn't know. It would be difficult to determine first order and second order in the web. So rather, what you can do is use announcement half-lives. You can use announcement half-lives, which is half-life is the time taken for the concentration of a reactant to fall to half its original value. The time taken for the concentration of a reactant to fall to half its original value. So, because of Manetta, guys, but go and look at this. So this graph could be used to determine order. However, it becomes unreliable to just look at shape. So you use something more reliable, which is called half-life. For example, if I wanted to check the order here, so let's just say I had a graph, was it determine order? Could you check the first order? Can I second order? Or not? So instead you use something more reliable, which is to say, you can pick a concentration and say concentration 1, and look for another concentration which is half this value. And this which is half this value, and you check how much time it took for concentration 1 when concentration 2 from the graph. And then what I do is I half this again. So I half this value. What is it? No, we have a graph which half that value. No, what is the time up? We are up. T2. So my half-lives you are look at. So this is half-life 1, half-life 2, half-life 3, change. So you do that for the whole graph. And anyway, so guys, don't worry about the camera. It's not important. So.